Alright, number 12. This is page 9. The first thing that you do is you look at it and you say, can it be factored? Are there two numbers that multiply to negative 84 and add to negative 10? And what if you're not sure? What could you do? Correct. You could graph it. Y equals n squared minus 10n minus 84. When I graph it, I see that it crosses through, but not at a whole number. It crosses through between negative 5 and negative 6, right? So that lets me know that there aren't two numbers that multiply to that and add to that. So I'm going to have to complete the square. What's the first step in completing the square? Right, I need to add this 84 to the other side. When I do that, it'll be n squared minus 10n equals positive 84 because I had to add it over. What's step 2? Take the b value, which is divide it by 2, which will be negative 5 squared will give you, okay, and you're going to add that 25 on both sides of the equation. It's part of the formula. You're going to have to watch videos. Okay, it's b divided by 2 squared. Will give you the number that you added on both sides. Okay, now on the left side, you factor. Because now we've created ourselves a trinomial that can be factored. What numbers multiply to 25 and add to negative 10? What kind of 5s? Both negative. And then on the right side, we just combine like terms. What's 84 plus 25? Right. Okay, so now, since these match, and they always will if you've done everything right so far, you can write it as a binomial squared, which means write it once, but since it's the same thing, just square it to show that there's two of them. Then on the right, you just bring down the 109. Now what do I need to do? Square root it so that I can cancel out that 2 and then square root this side. So now I have n minus 5 equals, this is not a perfect square, so it'll stay in there. Now the last step to get n by itself is what? Add 5 to the other side. And so in your calculator, you'll type in the square root of 109 plus 5 and the negative square root of 109 plus 5. Okay, so go ahead and type those in. Type in the square root of 109 and then on the outside plus 5 and then the negative square root of 109 on the outside plus 5. Negative goes on the outside, yes. Okay, so when you typed in the square root of 109 plus 5, what's your calculator say? 15.4. When you typed in the negative square root of 109 plus 5, what does your calculator say? Right. Okay, now let me show you something. Okay, pay attention. You don't have to do this. I just want you to understand why these are the solutions, okay? So just pay attention. Think about it. In factored form, wouldn't that 15.4 have been written n minus 15.4? And this negative 5.4, wouldn't that have been written n plus 5.4? Add those numbers together. Negative 15.4 plus 5.4. And isn't that what they should be adding to? Now multiply them. What's negative 15.4 times 5.4? Which is very, very close to negative 84. Why do you think it's not exactly negative 84? We rounded. We rounded off at 0.4, but there were a lot of digits. Had you actually typed in 15.44030651 times negative 5.44030659, it would have made exactly negative 84. But it's close enough to know that we did it right. Also, look at the graph. The one that we could see, doesn't that look like it's crossing through at about negative 5.4, which is what we got for one of ours? And then we can't see 15.4 because it would be over here off the graph. Okay, other questions from the homework? Yes, but you got to keep in mind that, like, you could multiply these and they would come up to something close to negative 84. But when you add these, they would make a positive 10 because in factored form it's the opposite sign. So you'd have to keep that in mind, that in factored form, these are the opposite sign. So these would add up to negative 10. So you just have to remember that. Okay, other questions off the homework?
11.
No. Nobody needs to see any more of these before we move on. 15? Turn around. People need to pay attention. Okay, number 15. Can that one be factored? Are there two numbers that multiply to negative 49 and also add to 4? If you're not sure, what can you do? Right? Y equals v squared plus 4v minus 49. We see it cross the x-axis at least right there and right there, but are those at whole number locations? No, and that confirms for us that we're not going to be able to think of two numbers that multiply to that and add to that, so we have to complete the square. So, Benny, the first step to complete the square is to add this constant to the other side. Okay, so what will it look like when I've done that? Right. Okay, then step 2 is where you do that b divided by 2 squared. Well, what number is in the b place of this trinomial? 4. Remember, all trinomials are in the form ax squared plus bx plus c. So the b value is always by the regular x, or in this case, the regular b. So it would be 4. 4 divided by 2 is 2. 2 squared is 4. You're going to take that 4 and you're going to add it in on both sides. Okay, now on the right side, it's easy. You just add them together and that becomes a 53. On the left side, you've now created yourself a trinomial that can be factored. You can find two numbers that multiply to 4 and add to 4. And what are those two numbers? 2 and 2. Now, what's special about this completing the square process is when you factor this at this point, these will always match. And the reason they have to is because in the next step, you're going to be able to write it once and square it, because there's two of them. Now that we only have one v, we're ready to get it by itself, because we're trying to find out what v equals. So to get that v by itself, we first start by square rooting it to cancel out that 2, and that means we square it this side. So now I have v plus 2 equals the square root of 53, and that won't become a whole number, so just leave it in there, but you have to put plus or minus on your answer. Anytime you're solving for a letter and you square root a number, you put plus or minus on it. Now, the last step to get v by itself is what? Right. Take this 2 and subtract it to the other side. So now your two solutions are the square root of 53 minus 2 and negative square root of 53 minus 2. So you would type them in like this. Square root of 53, but then on the outside of it, minus 2. And then negative square root of 53 minus 2. 5.3 and negative 9.3. And isn't that, on the graph, doesn't that look like about negative 9.3, and that looks about 5.3? Okay, also like John Michael was saying, think about it. Had you tried to do these in factored form, wouldn't this one have been a v minus 5.3 originally, and this one originally would have been a v plus 9.3? Because in factored form, they're the opposite sign of what they are in the final solutions. Well, isn't negative 5.3 plus 9.3 positive 4? And then when you multiply negative 5.3 times 9.3, you're going to get a number very close to negative 49. It won't be exactly negative 49 because we rounded the whole time, which made things, a little off, but it'll be close enough for you to know you did it right. Okay, any other questions off the homework before we move on? Okay, go ahead and turn to the next page. Okay, what we're about to do is just a review. Okay, so this isn't going to take us the remainder of class. I'm going to be introducing a new topic near the end. But there is one question on the test where you're going to have to remember this, so we're going to go over it. Number 1, they want us to identify the vertex, the direction of the opening, and the min or max value of each. Well, if I graph this, what kind of graph is it going to make? A parabola. How do you know that? Because it's squared, it's quadratic, which means it'll make a parabola. Okay, so let's look at it on a graph. What do I mean when I say identify the vertex? What is a vertex of a parabola? Where it changes direction. So in this case right here, correct? Where is that located on this graph? Negative 4, negative 1, right? Negative 4, negative 1 is the vertex. Now, didn't that vertex go to negative 4, negative 1 because, look up at the board, this x plus 4 inside caused it to move left 4 units, and this minus 1 on the outside caused it to go down 1. Remember that? The inside number goes left and right, and it's opposite of what you would think. Plus 4 is actually left 4. The outside number moves it up or down, and it is what you would think. Minus 1 is down 1. That's why the vertex is now at negative 4, negative 1, because it went left 4, down 1. Does this parabola open up or down? Down. How could we have told that just by looking at the equation and not a graph? The front number is negative. If your front number is negative, it'll open down. If your front number is positive, it'll open up. Now, does this parabola have a max or a min? A max. Anytime a parabola opens down, isn't the vertex going to be the maximum point? So it has a max, and the max is the vertex. So let's try number 2 without even graphing it. What will this x plus 4 cause the parabola to do? Left 4. What will the minus 6 cause the parabola to do? Down 6. So if your whole parabola shifts left 4 units and down 6 units, where does that place the vertex? Correct. Is the parabola going to open up or down? Down. And how do you know that from the equation? Because the front number is negative. Okay? And then if a parabola opens down, is it going to have a max or a min? A max. And isn't that max going to be the vertex? We're on page 10. Yeah. Okay. But like I said, if you're not able to do all of this without the graph, you can graph it. Okay, you have a calculator. You can always graph it if you need to. So let's look at number 3. What kind of shifts are going to occur? Left 5 because of that x plus 5, up 4. So if this whole parabola, this whole U-shaped graph goes left 5, up 4, where does that place the vertex? Correct. Is it going to open up or down? Down because the front number is negative 1. Isn't that a negative 1 out front? And then a parabola that opens down, is it going to have a max or a min? A max, and isn't the max always going to be the vertex? Or if it's a min, it'll be the vertex? Okay, number 4. What kind of shifts is it going to make? Correct. Left 4, up 3, which means the vertex is going to be where? Is it going to open up or down? Which means it will have a, and the max will be the vertex. Okay, number 5. What kind of shifts are you going to see? Right 6, up 2, which means the vertex will be where? Positive 6, positive 2. Is this one going to open up or down? Down because your front number is still negative. which means it will have a max, and where will that max be? Correct, the vertex. Okay, I'm doing one more with you. Where is the vertex going to be for this one? Use your brain. Okay, which way is it going to open? It's going to open up because the front number is positive 1/2. If it opens up, is it going to have a max or a min? A min. We just need to find out where that min is, and that's also your vertex. Think about it. Isn't this the same thing as y equals 1/2 times x plus 0 squared plus 0? They just chose not to write the zeros, and that's why it condensed down to 1/2 x squared. So if it moves right 0 and up 0, where's the vertex? 0, 0. Now, if you're having trouble with one like that, you should do what? Graph it. If you graph this, you'll see very quickly that when you graph 1/2 x squared, oops, too many x's. You will see that its vertex is 0, 0, which is also a minimum point, and it opens up. So anytime you're having trouble, just graph it and get a picture. Okay, I'm going to give you about 5 minutes to finish this page and the next, and then we're moving on. Here we go. Today we're going to start learning a new method to solve these. Okay, so we've learned how to factor when possible, and when we can't factor, we learned how to complete the square. We're also going to learn a method known as the quadratic formula. This is what the quadratic formula looks like. So, look, step 1, set the equation equal to 0. Well, isn't this one in example 1 already set equal to 0? So step 1 is done. Step 2, identify your A value, your B value, and your C value. Put it away, Ben. Well, I'm going to call her and let her know. AX squared plus BX plus C. That's what all quadratic trinomials look like. So, knowing that, what's the A value of our example? 1. Isn't there an understood 1 in the A place? What's the B value? And what's the C value? 3. Now all you're going to do is you're going to substitute those 3 numbers in the formula where they go. So like every time you see a B, you're going to put a 5. Every time you see an A, you're going to put a 1. And when you see the C, you're going to put a 3. So it'll look like this. X equals negative B, which will be 5. And anytime you're substituting in a number, put parentheses around it. Plus or minus the square root of B, which is 5, squared, minus 4 times A, which is 1, times C, which is 3. All over 2 times A, which is 1. Okay, so see how all I've done so far is rewritten the quadratic formula, but every place I saw a B, there's now a 5. Every time I saw an A, there's now a 1, and the C is replaced with a 3. That's all I've done so far, is plugged in the numbers where they go. Now I have to simplify it. The first thing you're going to do when simplifying is negative 5 is just negative 5, okay? Plus or minus. I want you to type in 5 squared minus 4 times 1 times 3. Not the actual radical, just everything up under it. 5 squared minus 4 times 1 times 3. What do you get when you type in 5 squared minus 4 times 1 times 13? So that goes back up under the radical because we didn't do anything with it yet. And then all over, what is 2 times 1? 2. So now here's how you're going to get your 2 answers. Watch me on the calculator. Well, I'll give you time to copy and then I'm going to do it on the calculator. Okay. So look, it's a fraction that I'm going to be typing in, right? This is a big fraction. So I'm going to set up for a fraction by going to alpha y equals n over d. I'm going to type in negative 5 plus the square root of 13, and then on the denominator 2. Okay, see how I just typed in everything you see, except for when I got to this part, I typed in the plus. So that means in the next part, I'm going to type it in, but I'm going to type in a minus. Oops, but I got to make it a fraction first. Hold on. Okay, so alpha y equals n over d. Negative 5 minus the square root of 13. And then over 2. So does everybody understand what I've typed in here? I've typed in this, but I typed it in the first time with the plus and the second time with the minus. And then these are my two answers. Negative 0.7 and negative 4.3. Now, we could have gotten those same answers if we had just completed the square. Okay, so has everybody copied this? Okay, watch. I'm going to do it really quickly, okay? I'm going to complete the square really fast. Okay, the first thing I would do is move the constant, so that would become x squared plus 5x equals negative 3. Then I would take my b divided by 2 and square it. And I would add that number into both sides. However, what's my b value? What's 5 divided by 2? And what, 2.5. And what is 2.5 squared? 6.25. So see how messy that's getting? See how that's getting with a decimal because your b value is an odd number? That's why we need to have another method, the quadratic formula. Okay, you could continue this. There are numbers that multiply to this and add to this. It's 2.5 and 2.5. But do you really want to have to go through all that with decimals? No. So that's why we have a new method called quadratic formula, and we will continue working on it tomorrow. You can switch out.